Learning Target 4.3 says I can correctly use IUPAC rules to name binary ionic compounds. So IUPAC is International Union of Pure and Applied Chemistry. They make all the rules concerning naming and formula writing. So to name ionic compounds, the first thing we're going to do is name our cation. Now remember that that's our positive ion. It's the one that always comes first. Okay? Then we're going to name our anion, which is our negative ion, the second one. And we're going to change the ending to IDE. So what that's going to look like, VABR2. All right, our cation is barium. Our anion is bromine, so we change the bromine to bromide. So the name of our compound is barium bromide. Ki. K is potassium. That's our cation. I is iodine. So we change the ending to iodide, and we get potassium iodide. Now when you have a polyatomic ion, you're going to name the cation the first one, the positive one. Then we're going to name our anion. Now here's the catch. You never ever change the ending of a polyatomic ion. So for example, NaNO3. Na is our cation, that's sodium. NO3 is on our list. It is nitrate. So the name is sodium nitrate. CaOH2. Alright, Ca is calcium. OH is on our orange sheet. That's hydroxide. So calcium hydroxide. Now IDE here comes because that is the name of the ion. NH42SO4. Alright, NH4 is on your list. It is ammonium. SO4 also on your list is sulfate. So the name is ammonium sulfate. Notice we did not change any endings here. Those are polyatomic ions. NH4Cl. Alright, NH4 again is ammonium. Now Cl is chlorine. It is not a polyatomic ion. So you are going to change the ending for chlorine to chloride. So the name of that one is ammonium chloride. We're going to do lots of practice in class. So we're going to name ionic compounds that have transition metals. And as you noticed in our practice problems, you had to be told the charge using a Roman numeral. So the first thing we need to do to name a compound with a transition metal is we have to determine the charge by using the charge on your anion, your negative ion, and your ratio. Once you do that, you're going to name your cation, you're going to indicate the charge with Roman numerals, and then you're going to name your anion inappropriately, depending on if it's an element or a polyatomic ion. So let's look at some examples. So we have CuCl2. So the first thing we need to do is see that copper is a transition metal, so we need to determine its charge. So we know that chlorine is -1. We're going to unflip the ratio to find these charges. So our ratio is 1 to 2. So here's what our formula looks like. Remember that the -1 on the chlorine gave our copper its 1 subscript. So that means the 2 here gave copper a +2 charge. So we have a Cu with a +2 charge. So we name it copper 2. We name it chloride because it's chlorine from the periodic table. So we have to change the ending to IDE. So the name of this compound is copper 2 chloride. Let's look at another one. FeNO33. Now here we have a polyatomic ion. So the first thing we're going to do is determine the charge of our iron. Now we know that nitrate is -1 by looking on our sheet. So again, we're going to unflip the ratio. We know our ratio is 1 to 3. Now we have to use this 3 outside the parentheses. The 3 inside the parentheses goes with the nitrate. Okay, so use what's outside the parentheses. So FeNO33 here, we know that nitrate's -1. So that's where we got our subscript for the iron. Then our 3 on the outside of the parentheses tells us we have a +3 charge on iron. So Fe3 plus is iron 3, and our anion is nitrate. so iron 3 nitrate. NiSO4. We're going to determine the charge on our nickel. Alright, we know that sulfate's -2, so again we're going to unflip. But now pay attention here. The ratio is 1 to 1. Okay, because if we look at this with parentheses, it's 1 nickel to 1 sulfate. Now we do know that sulfate is -2, so we have to be very careful here. Okay, even though there's no 2 there on the nickel, it's a 1 to 1 ratio, so that tells us that our charges have to be the same. So you have to pay attention to the ratio here. If it's 1 to 1 and sulfate's -2, that means nickel also has to be +2. So we name our compound nickel 2 sulfate. Let's look at one more. PbO2 is our compound. We're going to determine the charge of lead. Now, even though lead's in the carbon family, it's still, well, in the carbon column, it's still part of the transition metal family. We know that oxygen is -2, so again, we got to be careful. Our ratio is 1 to 2, but we have 2 oxygens at -2. Alright, so notice there's no 2 on lead. If we have 2 -2 charges, that gives us an overall charge of +4 for our lead. And if we flip that, we get a ratio of 2 to 4, which reduces to 1 to 2. So we always want to make sure we use the smallest ratio here. So that tells us that we have lead 4, and 4 is IV in Roman numerals. Alright, and of course oxygen becomes oxide, so lead 4 oxide is our compound.